In December 2020, the FDA authorized 2 coronavirus vaccines, both with unexpectedly high efficacy. Let's look at what we know about these vaccines and what we have yet to find out. The first vaccine to be authorized was developed by Pfizer and BioNTech, and the Moderna vaccine was authorized a week later. Both are messenger RNA or mRNA vaccines. They work by inducing an immune response to the viral spike proteins. These are the proteins that stud the surface of the SARS-CoV-2 virus and make it look crown-like, which incidentally is where the coronavirus gets its name. You can think of the vaccines as target practice for your immune system, the target being the spike. But instead of the actual spike proteins, these vaccines contain the genetic information in the form of mRNA that codes for the spike. When the vaccine mRNA enters the cells in your body, it gets taken up by the machinery of those cells, which then make the spike proteins.
So we're basically just using the machinery of the cells to produce spike protein and put it in the surface of the cells so the immune system can then come and see the spike protein and then generate an immune response.
This immune response to the spike would help you fight a future infection with the SARS-CoV-2 virus. Importantly, the vaccine mRNA does not enter the cell nucleus, which contains the cell's DNA. So the vaccine has no effect on DNA or body genetics. The vaccine mRNA also does not replicate, and it does not stick around permanently.
The mRNA disappears, it goes away, so it doesn't even stay in the cytoplasm of the cells. This is what the cells normally do. mRNA in our cells disappears after it forms proteins.
Data suggests the highest levels of spike protein are produced 48 hours after vaccination and are cleared by 72 hours. The mRNA is actually gone even sooner, by 24 hours. Now let's look at the data on efficacy. The overall efficacy for these vaccines was determined by comparing the number of people who developed symptomatic COVID-19 in the vaccine and placebo groups in large phase 3 trials. Here are the numbers for Pfizer and for Moderna. So how do you calculate efficacy? Let's look at Pfizer. First, you divide the cumulative incidence of disease in the vaccine group by the cumulative incidence in the placebo group. This gets you the risk ratio. Then you subtract the risk ratio from 1, and the number you come up with is the efficacy. So the efficacy for Pfizer is 0.95, or 95%. Here again are the numbers for Moderna. Using the same calculation gets you an efficacy of 94%. These numbers are encouraging. But it's important to keep in mind that participants in both the Pfizer and Moderna trials were tested only if they developed symptoms of COVID-19. So while these data tell us if these vaccines prevent clinically recognizable disease, they do not tell us if the vaccines also prevent infection and transmission of the virus, which means a few possible scenarios could be at work for those who are vaccinated.
So, a typical scenario could be A, that someone is protected against infection, and certainly, if against infection, against clinically recognizable disease. But there's also a likely scenario where someone is protected against clinically recognizable disease, but they still have replication-competent virus in their nasopharynx. Hence, by definition, they are infected.
And if that second scenario is at play with these vaccines, that is, that people who are vaccinated don't develop symptoms but still get infected, a follow-up question is whether these vaccines might still prevent or at least decrease transmission. According to Dr. Fauci, it is conceivable that the immune response that protects someone from symptomatic COVID-19 would also lower the amount of virus in the nasopharynx.
So you could be infected, but not have enough virus in your nasopharynx to transmit it.
Studies are already underway to figure out whether these vaccines prevent infection and transmission as well as symptomatic COVID-19. Some very preliminary data indicate that they do, and more data are expected soon. But given the uncertainty, public health authorities are recommending continued preventive measures like mask wearing and physical distancing, even for people who have been vaccinated. And there are other unknowns when it comes to efficacy that are still being researched, like the duration of immunity, whether the new virus strains could make the vaccines less effective, or how efficacy varies for different demographic groups.